First thing I'm going to be doing is one more shot at the trig ratios when you're told a terminal point. Don't really need to use these numbers right now, but we do need to use these 6 formula. Each one gives you one of the 6 trig functions. So let's just jump right in. Here is my terminal point. So that's obviously my x coordinate is that, and my y coordinate is that. And so if you want to do the sine, it's just the y coordinate. And so pretty much you just write down the answer. And if you want the cosine, it's the x coordinate. Again, you just write down the answer. If you want the tangent, it's the y coordinate divided by the x coordinate. And the y coordinate in this case happens to be 3 root 10 over 10. And the x coordinate happens to be root 10 over 10. You try and separate these things with a little wall. Okay. Right, we told you yesterday that it's a nice little shortcut. Aren't you allowed to cancel these 2 10s? And so this ugly fraction divided by that ugly fraction just turns into 3 root 10 over root 10. And sometimes, not always, you get this. Oh, and those cancel. So the final answer ends up being 3. So far, so good. Now, if you want to do the cotangent, you essentially switch places. And I'm going to show you a little shortcut in the cotangent in a minute. But if you want to do the cotangent, it's the x divided by the y. And so it's root 10 over 10 on the top and 3 root 10 over 10 in the bottom. And if you cancel the 10s, you get 10 over 3 root 10, but those in turn cancel, so you end up with a third. And so here's a little shortcut. The tangent and the cotangent are in a way paired together. Have you noticed that the tangent and the cotangent are reciprocals of each other? Well, that means that it's like one over the other. So if you know the tangent is 4, the cotangent is going to be a quarter, in which case you don't need to do any work, right? If the tangent is 7, won't the cotangent be 1/7? If the tangent is a half, won't the cotangent be 2? Do you see where I'm going with this? So you can save yourself a little bit of work if you want to do that, right? That's a shortcut. In fact, a secant is the reciprocal of a cosine, and a cosecant is the reciprocal of a sine. So you can use that shortcut with all of them. But I'm just going to do these last 2 the way they are. So it's 1 over y, which is 1 over that guy. Right, well, you know, if you take a fraction and you do 1 over it, it's called its reciprocal. You essentially turn the fraction upside down. So instead of root 3 root 10 over 10, you now get 10 over 3 root 3 root 10. And then we have to kick in with style points. I hope you agree that we've kind of pushed this rule that you really should avoid square roots on the bottom, right? Fractions don't work well with square roots on the bottom. So I'm going to do a square root of 10 top and bottom. And what that's going to give me on the top is 10 square root of 10. And on the bottom, well, square root of 10 times itself is 10, but you've got 3 of them. So 3 lots of 10 get me 30. And then a little bit cancelling the 10 and the 30. And what do I get? Well, I get root 10 over 3. So that's the final simplified answer for the cosecant. And the last one of this set then is the secant, which is 1 over the x. So it's 1 over this fella. And the reciprocal of that guy is essentially just turn them upside down. So you get 10 on the top, root 10 on the bottom. Same kind of problem as we have here. So we'll rationalize the denominator by multiplying both the top and the bottom by root 10. The top becomes 10 root 10, and those two get you 10. Oh, and then the 10s cancel, and you get root 10 when you're finished. That's pretty much it. Would you agree that if you know the terminal point, it's not that difficult because you've got formula to find the 6 trig ratios? Great. This one here happened to have all positive numbers, but I'll show you how easy it is if it was negative. Suppose that the one there was negative, just for argument's sake. Then what would happen is, wouldn't this be negative? Wouldn't this be negative? What else would we get? On this one here be negative. And the cosine would still be positive. And what about the cotangent? Well, ends up being negative. And finally, what would happen to this guy? This guy happens to be positive. So out of those 6 ratios, if you made this guy negative, then these answers all end up being negative. And these 2 answers end up being positive, right? But the numbers don't change. You know, it's still root 10s and root 3s and whatever else is going on. So far, so good. Would I be comfortable in assuming that if I gave you any P, you could do these 6 guys? Do you feel, yeah, I could do them? Yep, got nods. So let's return to a guy called the quadrants. We talked about them once before. Essentially, if you think of starting off at 0 and doing your usual anti-clockwise, you know, turning of your minute hand, we have any angle that's between 0 and pi upon 2 is said to be in quadrant 1. If you're an angle between pi upon 2 and pi, then you're in quadrant 2. This region over here is quadrant 3, and this region here is quadrant 4. You remember? 1, 2, 3, 4. If you're in quadrant 1, aren't both coordinates x and y positive? If you're in quadrant 2, the x coordinate is negative, but the y coordinate is positive. If you're in quadrant 3, both x and y are negative. And if you're in quadrant 4, the x guy is positive and the y guy is negative. You remember doing that? Okay. So this is just rehashing something. So what we're now going to look at is in the 4 quadrants, right? We're going to look at the 4 quadrants and the trig ratios. And in particular, we're going to look at when these guys are positive numbers and when these guys are negative numbers. So let's take, for instance, the first quadrant. In the first quadrant, since the x coordinate is positive and the y coordinate is positive, let's not worry about these 3. We're only going to focus on these ones. Would you agree that the sine, the cosine, and the tangent are all positive? So in the first quadrant, all of them are positive. And so when I write the word all, I mean sine, cosine, and tangent is a positive thing, right? Now, if you move over to the second quadrant, right, this one here, the x is negative and the y is positive. So the y is positive means the sine is going to be positive, agreed? The x is negative, so the cosine is going to be negative. And since the tangent is made by dividing these 2, isn't the tangent also going to be negative? So if I said what's happening in the second quadrant, you could say the sine. And what I mean by that is the sine is the only one of them that's positive out of that 3, right? The sine is the only one positive. And by implication, then, doesn't it mean the other 2 are negative? Okay, let's move into the third quadrant. Which one of these 3 guys, keep hiding these because I don't want to talk about them. Which one of those 3 guys is the only one that's positive when you're in the third quadrant?
The tangent.
Agreed. Would you agree? Y coordinate's negative, x coordinate's negative, so those 2 are negatives. Isn't the tan a negative thing divided by another negative, which makes it the only one that's positive? So we're now into the fourth quadrant. For any angle from essentially, I guess, 3/2 back to 2 pi, Probably would. If you go all the way around, if you start at 0 but you finish back at 0, it's 2 pi. In the fourth quadrant, which is the only one that's positive? Which one of those three is the only positive one?
Cosine.
I agree, it's a cosine. Now, you need to remember these regions, not just the first, second, third, fourth, not just when things are plus and minus, but also a new piece of information that in the first quadrant, everybody is positive, then it's a sine, then it's a tangent, then it's a cosine. And there's a little mnemonic that we can use to help you remember the order, right? All, sine, tan, cos. I don't know if you've heard of this. Here it goes. All smokers take cancer. That's a kind of depressing one, but it helps you remember it, right? All sine, tan, cos. All smokers take cancer. If you don't like that one because it's depressing, you can do all students take calculus. It's just a little phrase, you know, like Sokatoa. I don't know if you haven't done that yet, but some of you have heard of the one Sokatoa. Isn't that another one of those ones that helps you remember things? So all smokers take cancer, or all students take calculus, whatever one you want to do. But now we know all of this information essentially in one nice little tidy package. So what kind of questions are we going to be dealing with? Well, I got that guy sorted out. Yeah, hide that. That's for later. Questions 18 to 23 are going to use this information. And I'll show you straight off the bat what which one will I pick. Yeah, how about this one? This is question 20. In question 20, they say, find the sign. That means tell me if it's positive or negative. That's your only two choices. For the cosine of t times the secant of t. And the only two choices are that that is always a positive answer. And the second one is it's always a negative answer. Right. Now, you know how I was covering these guys up because they kind of distracted us. Let's bring them into the fray. If the sine is y and the cosecant of is 1 over y, then won't the secant and the sine be the same sign? So if the sine is positive, so is the secant. Does that make sense? And if the cosine and the secant here, or the tangent and the cotangent, whatever the tangent is, the cotangent is. But the reason we don't put it in there is it clutters up the picture. Wouldn't it be really messy if I said all cosecant sine, tangent cotangent, cosine secant? Would you? I mean, that's just too much information, right? It's hard to keep track of. So all you need to remember is that if the sine is positive, so will the cosecant. If the tangent is positive, then so will be the cotangent, right? So let's look at that question again. They don't tell me which quadrant it's in. So let's go through all the possible choices. So I'm going to figure out what's happening in each of these 4 quadrants. Right, in the first quadrant, since everybody is positive, won't 2 positive things give me a positive answer? Does that make sense? In the first quadrant, that's positive, and in the first quadrant, that is also positive. So won't those 2 things be positive? Now, what about in the second quadrant? Well, in the second quadrant, what do you know about the cosine? Well, you have to kind of work backwards. In the second quadrant, the sine is positive. Well, doesn't that make the cosine negative then? Because that's the only one that's positive. Now, what about the secant? Oh, isn't the secant the same thing that the cosine is? Isn't the secant the same thing as the cosine, right? So they're both negative. And if they're both negative, doesn't that make the answer positive? You see where this is going? Now, if I tried the other three, you can check them out. They're all positive. And so the answer was positive. Now, if I was really wanting to be efficient, didn't I only need to check the first quadrant? Because if the answer is positive, doesn't it have to be positive all the time? Because the question says, is it always positive or always negative, right? It never gave you a choice, right? It had to be one or the other all the time. How about this one? The cosine of t is in the third quadrant, and the sine of t is in the second quadrant. Is this going to be positive? Or is this going to be negative? So that's my first question. If I tell you that the cosine of t is in the third quadrant, and I tell you that the sine of t, well, I shouldn't really say is in the second quadrant, but it is, right? I'm telling you those two things. What can you tell me about the product of these two things? Well, in the third quadrant, the tangent is positive. Well, if the tangent is positive, doesn't that make the cosine negative? Okay, in the second quadrant, is the sine positive or is it negative? In the second quadrant.
Positive.
Right. And what would you get? Kind of silly question to ask, but here we go. What would you get if you multiplied those two things together?
Negative.
And that's how you tell. Now, since a lot of these questions are positive or negative, can you imagine, since you've got 5 guesses, it won't take you long to get the right answer. But I don't want you just to randomly guess, and if you get it wrong, you pick the other one, because then you're not going to be able to do that question in the midterm, for instance, because in the midterm you won't know what it is. But here's a more trickier question. Same information. Right, or similar information, I should say. Sine squared t times cos squared t. Is that positive or negative?
Positive.
I like your answer. Now the hard part, prove it to me, because you're right.
Well, everything squared would be positive.
Oh, that's an even better way of doing it. Never saw that for a minute. Yes, everything squared is positive. I was hoping that you would have said something like negative times itself is positive, but the way you said it is totally correct. So in that question there, you choose positive. Okay, let's try another one of these. So all we're being asked here is something positive or negative, right? Given some, information to do it. So how about I tell you that the sine of t is in third quadrant, and I tell you that the tangent of t is in the fourth quadrant. And then I'm going to ask you, which quadrant is angle T in? That's a little bit of a puzzle, right? Let me get my little all sine tan cos thing. So I'll do a little baby version of it. Right, so we have all sine tan cos, right? Now the first thing says, oh, shooting space. I apologize. That's what I meant to write down, right? Because it doesn't make sense. You can't be in two quadrants at once, right? So I'm telling you that the sine of t is positive, and I'm telling you that the tan of t is negative. Now the question makes sense. In which quadrant is angle t in? So you go all sine tan cos, and if I tell you that the sine of t is positive, which quadrants does the angle have to be in if the sine is going to be positive?
1 or 2.
You all agree on that? Everybody's positive in one, and isn't sine the only one? So pull the asterisk. Now, if the tangent is negative, and be careful here, it's negative. So think oppositeness now, yeah. Which quadrants could it be in? There's 2 of them, agreed? One of them is 2. Where's the other place where it could or it might be?
4.
4.
3. All right, 4.
4, right? Remember, it's negative, right? Now, when you look at this pattern, do you see there's only one quadrant where both things are true? So the answer to this question is quadrant 2. Does that make sense how we kind of figured that out from the information that was given, right? So if you tell me, you know, if I tell you any two of the 6 trig functions, you should be able to figure out which quadrants it's in. So here is one of the ways in which they phrase this. This is a version of question 21. Sine t is greater than 0, and cosine t is less than 0, okay? And we're being asked to find which quadrant the terminal point t is in, right? So which quadrant is the angle in, is how I would phrase it. So here's my all sine, tan, cos thing going on. There's the first, second, third, fourth quadrant. Okay. Would you agree, because I already did it, isn't the sign greater than 0 means when is it positive? So that makes it these 2 quadrants, right? When is the cosine less than 0 is just another way of saying when is it negative. So which 2 quadrants is the cosine negative?
The second and third.
And oh, by sheer coincidence, doesn't the answer happen to be the second quadrant again?
Yes.
That's sheer coincidence, right? You could get the answer in the 4th, right? You could get the answer in any of them, right? It just happens to be the 2 I've done, happen to be the same. Do you feel comfortable about this kind of which quadrant am I in, or am I plus and minus?
I was just confused when you explained 20 when you went on the other page.
What this is that what you're thinking?
Yeah.
Okay.
Because in quadrant 2, they're both negative, so like.
But when you multiply 2 negatives together,
Oh, it's
it's
a
a
multiplication.
positive answer.
I see that
that's
now.
it. Does that
I
help?
couldn't read it. Okay.
Right. No, I like questions. I'm sure other people were thinking the same thing. Let's do one more just for fun and giggles. The cosecant of t is greater than 0, and the secant of t is less than 0. So we have 2 pieces of information, as we always do in these questions. And we have to figure out which quadrant the angle is in. I think they phrase it as which quadrant is the terminal point in. It's the same thing. The cosecant is positive. I don't have any cosecants in this little table, right? But doesn't the cosecant behave just like the sine, right? cosecant is the reciprocal of it, right? So whatever the sine does, the cosine does, the cosecant does the same, right? So whatever the sine is, so is the cosecant. So really, isn't that just telling me that the sine of t is positive? Do you see how I interpret that? So now I know the sine is, oh, not another one. It's going to be in the first and second quadrant. I don't think they have any imagination in what we're saying. Okay, maybe we'll get lucky on the next one. But see if the answer to this is the second quadrant. Will you just take me, you know, I don't know what to say. It's a fluke. That means I got 3 second quadrants in a row. But who does the secant behave like? Sine, cosine, or tan? Who does the secant behave
Cosine.
like? Cosine. So aren't you basically saying to me the cosine of the angle is negative? And the cosine is negative. Oh, darn it in space. Guess what answer the angle is in? I can't say this often enough. Will you not just say, the answer is always the second quadrant, don't even read the question. Right, it's not. I mean, I don't know how to undo this, except to say I'm very bad at randomly picking questions. Right. Are we good? So, is it comfortable then that we can move on from these 18 to 23s? Feel, because they're all, is it plus or minus, or which quadrant is it in, right? That's the 2 kinds of questions we've covered. Are we good? Last chance. Okay. So the next thing we're going to deal with is the situation. And these are questions 24 to 27. And we're going to try and find all 6 trig ratios when the only information that you're given is one of the trig ratios and the quadrant. So they're not going to give you that pretty straightforward question that we started today with, if I can find it, where they tell you the coordinates of the terminal point, you know, this guy, and then off you go, and you know, this is the x, this is the y, and then you plug them in, right? This kind of question, they're going to tell you, well, let's show you one right off the bat. This is question 24, and you're being told one of the trig ratios. You're being told that the sine is negative 4/5, and you're being told that t is in the 4th quadrant. And only with that piece of information, or this bit of information, we are somehow eventually going to get the other 5 trig ratios, right? These other guys here. And so this is much more, there's more detail in this, right? You have to do a lot more work to get your answer, right? It's not like, oh, plug it straight in. So I'm going to start with an obvious thing, because there's always an obvious one, hopefully, within these. Do you see this guy here, sine t? Isn't he the y coordinate? So what do I know? I know the y coordinate is negative 4/5. That's good, right? Good. Knowing the y coordinate is useful. Don't I just need to find the x coordinate and then I can do this? So that's my goal. Find the x coordinate, right? I know the y. How do I know it? Because the sine is the y coordinate, right? Well, I'm going to use this guy that we haven't used for a day. Remember the equation of a unit circle? And I know that the y coordinate is negative 4/5. And if you multiply that by itself, you get 16/25. You were looking puzzled a few seconds ago. Are you okay, Katie? Or is there something you want to ask me?
No, I'm good.
You were, so you weren't really puzzled, you were just thinking, right? Okay, because sometimes the two things look the same. Okay, well, you know how we do this, don't we? As long as you do it to both sides, it's okay, rule. So can you trust me that eventually you get 9/25, but you would do it in your calculator and make sure. Right. And there we go. The x squared is 9/25. So what do we do next to both sides?
Square root.
Okay, now that's where the problem kicks in. That one actually simplifies really nicely. It ends up being plus or minus 3/5. But the problem is, which one is it? Is the x coordinate 3/5 or is it negative 3/5? You're right, you have a decision to make and you can't just guess. So let's see
It's
if we can
negative.
bring, oh, let's see where he got that from. There's my first quadrant, there's my second, there's my third quadrant, and then there's my fourth quadrant. In the fourth quadrant, right, you're in the fourth quadrant. What is the x coordinate?
Positive.
And the y coordinate?
Negative.
And which one of these then are we going to use?
Positive.
Because it's the x, right? So, are you happy about why I picked 3/5 and not the alternate choice of negative 3/5? Are we good? Now, once you've done that, you now know the coordinates of the terminal point. The x coordinate, we just found out a minute ago, is 3/5, and the y coordinate is negative 4/5. And at this point, I'm going to stop for a moment. Once I know that guy, can't I find all 6 of these? Can I just not bother doing it because I think you'll have plenty of practice to do it anyway, right? And it's just going to be busy time. I mean, you've probably done about 10 of them by the time you get here. So this should be second nature, right? You get the sine, you get the cosine, you get the tan, then you turn them all upside down to get the other 3 and boom, you've done. Do you want me to go through that step or can we just say, yeah, I can finish it from here? Can we do the yeah, I can finish it from here?
Yeah.
Good. I didn't want to do that. It's kind of boring, isn't it? Once you've done about 10 of them, you really, you know. Well, I've done a lot more than 10 in my life, so I'm allowed to be a little bit lazy. Are you comfortable about the strategy that we used to do that particular question? Right? So let me show you another one, but I'm just going to do the same thing, right? I'm only going to get to the point where I know the coordinates of the terminal point, right? The P. Once I know the X and Y, can't we stop there and you can say, yeah, I can finish it from here, right? Now, in this particular one, which is a version of question 25, we're being told that the secant of the angle is 3 and that T is in the fourth quadrant again, okay? Now this one involves an extra step. I'm going to be using in a few minutes that guy. Because I need to find the X and Y coordinate. Now the secant of T really isn't very helpful here. So I'm going to use a little property. Isn't the secant and the cosine like partners? In other words, if I know the secant is 3, don't I also know what the cosine is? Isn't the cosine 1/3? Does that make sense? Sine, cosecant. Cosine with secant. Tangent with cotangent. It's like husband and wife, right? A partnership, right? Whatever you are, I'm the opposite, right? Kind of thing. So now that I know that, I'm going to say, oh, what does the cosine tell me? Oh, the cosine tells me the X coordinate. So essentially, don't I now know the X coordinate is 1/3? Yeah, is 1/3. So 1/3 squared plus y squared is 1. 1/9 plus y squared is 1. Subtract 1/9 from both sides and you get 8/9. Take the square root of both sides and you're going to get the square root of 8/9. And that separates into the square root of 8 on the top and the square root of 9 on the bottom. And that turns into 3 on the bottom. Here's a sneaky one for you. You know that you can simplify some square roots. Now, obviously, the square root of 9 is 3. That's a definite simplification. But does anyone remember what the simplified version of the square root of 8 is? Because you should do that as well when it happens.
2 square root 2.
Correct. It's 2 square root 8. For those who kind of need a little reminder how that works, you think of the square root of 8 as being 4 times 2. You then split it into the square root of 4 times the square root of 2, and that gets you 2 times root 2. So I now know the y coordinate, except I have the same problem, don't I? Is it the plus version of the answer, or is it the negative? Now, in the 4th quadrant, which is down here, isn't the x positive and the y is negative? Right. So we are looking for the y coordinate. Is it plus or minus? Would you agree in quadrant 4, the y coordinate is negative? And that is where I got that. That's how I figured out that was my y coordinate. Does that make sense? I now know the coordinates of our terminal point. It's 1/3 -2 root 2 over 3. And then from there, can't you do sine, cosines, and so on? So dot, 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 right? So the goal that I'm doing here is I'm just going to take the information that they give me and find the terminal point. And once you get that, then you can use these to get the 6 trig ratios. So if you let me skip the last one, you're going to let me skip this one, right? Okay, good. Any questions so far? How are we doing? Is no questions a good sign or a bad sign? It's a good sign, right?
Yeah, I think it's a good sign.
It's a good sign, good. I don't know if I need to do one more of these. I guess I probably should. Okay. This next one is, oh, there's some notes from my Calc 1 class. Don't need that. Okay, I'll get rid of that too. Question 27. Oh God, a bad joke just came into my head. Got to get it out. Right. Did I tell you the joke about the Scotsman and his wife that go to America?
Yes, I think you did actually.
Okay.
For the plane?
The plain one.
Yeah.
Oh, I'm going to have to tell you another plain one now then. Scotsman, American, and a Frenchman are on a plane. And they're flying across the Atlantic Ocean. And the pilot gets on the radio and says, we're in real trouble. He says, we lost all our parachutes. We don't have any. We lost half our fuel. And we're too heavy. We don't have enough fuel to make it to land. We're going to crash into the sea and die. So the only thing that can save us is if we lose weight, and we've lost everything we can. So I need a volunteer. So the Scotsman and the Frenchman and the American just stare at each other. And after about 5 minutes, the Scotsman gets out of his seat. He says, oh, I've had enough of this. And he goes over to the aircraft door and he opens the door and he shouts, for the glory of Scotland, and he jumps out. And the door shuts. And the radio, the guy in the radio, the pilot gets on and says, that's great. He says, we lost a lot of weight there, but still not going to make it. I need one more volunteer. So the Frenchman and the American just stare at each other and nobody's moving. So after 5 minutes, the American gets out and says, oh, I've had enough of this. And he goes over and he opens the door. And he shouts, for the glory of America. And he throws the Frenchman out. Oh, God. You know, I've came to the conclusion, as long as I insult everyone by the end of the, you know, the 10 weeks, then it's okay. So if any of you have got French ancestry, you've took your hit, right? So hopefully I'll get round to every nationality before we're finished. I like that joke. Have you noticed that Scottish jokes tend to have, oh, by the way, in Scotland, that joke has changed. Do you know what they do in Scotland? They throw the Englishman out the plane, but that's just a slight difference to the story. It's essentially the same. Okay, right, 27. In a nice way, if I tell really bad jokes, don't you want me to get back to the work, so I'll stop telling them? So it's a kind of motivation thing. The other way I
I think the
motivate you.
joke's great.
Oh,
We're laughing. We're just all muted.
okay, right. So here we go. In question 27, you've got the sine of t is -1/4. And you're told that the secant of t is less than 0. And obviously we're going to find all 6 trig ratios. So here's my all sine, tan, cos thing. If I tell you that the sine of t is -1/4, right? So if I tell you the sine of t is -1/4, does it not make it, it has to be in one of these 2 quadrants here? Would you agree? The only places where the sine is negative is in these 2 quadrants. Agreed? Now, if the secant of t is less than 0, is it not the same thing as what the cosine is going to be? So won't the cosine be less than 0? Which quadrants is the cosine going to be less than 0? So I think I saw a 2. And where else?
3.
And 3. And so the answer is it's in the 3rd quadrant. Do you see in this question here, then they kind of disguise the information to make it a little bit harder to figure out which quadrant you're in. Now that I know that the answer is in the 3rd quadrant, right? The angle is in the 3rd quadrant. Does it not make the x a negative and the y a negative? Right. And since I know that the sine of t is -1/4, that makes that part, right? Would you agree? I know y coordinate is -1/4. So to finish this question off, let's find out what the equivalent x coordinate would be. So there's our unit circle. Oh God, that's 1/16. That's not a very pretty number. Subtract 1/16 from both sides, and you get that. And you take the square root of both sides. Now, let's save me writing a little bit more. Don't I now know that that is the negative square root that we're going to use? You agree? So I don't need to do that plus minus and then later on tell you it's negative. Secondly, shouldn't this be simplified at least as much as it can be? Agreed? Square root of 15 on the top and square root of 16 is 4 on the bottom. And in this case, isn't the square root of 15 as good as it's going to get? You know, like the square root of 8 could be simplified, but the square root of 15 can't. So we are done.